Biosensing instrument opens a new frontier in the research of label-free molecular interactions by introducing SPRm 200, the world's first commercially available instrument that combines surface plasmon resonance technology with optical microscopy, known as SPR microscopy. Designed specifically for label-free measurement of in vitro cell membrane proteins, SPRm 200 allows you to study drug targets' binding kinetics, as well as detecting and monitoring viruses and bacteria binding activities with antimicrobial drugs. In SPRm 200, monochromatic light is reflected off the back of a sensor chip and onto a detector. At a certain incident angle, known as the resonance angle, light is absorbed by electrons in the metal layer of the sensor chip, causing them to resonate. This results in an intensity loss of the reflected beam and can be seen as a dip in the SPR reflection intensity curve plotted against the incident angle. These resonating electrons, known as surface plasmons, are extremely sensitive to the surrounding environment. By monitoring the shift of the SPR dip over time, the affinity and kinetics of molecular binding events can be studied. Binding affinity and kinetics can be measured through a sensorgram, which plots the SPR response versus time. This sensorgram provides the association constant, Ka, and the dissociation constant, Kd. The binding affinity can also be derived. In SPRm 200, the cells are grown directly on the sensor chip, allowing the membrane proteins to be in their native environment. With SPRm 200's autosampler, drug targets are delivered to the sensing area, and together with Biosensing instruments' patent-pending technology, the simultaneous spatial visualization of cellular structures and real-time interaction measurements of the drug and membrane proteins can be done in vitro without the need to extract proteins from the cell. SPRm 200 seamlessly integrates SPR with optical microscopy, and its large field of view and high optical magnification allows the mapping and quantification of binding affinity and kinetic responses of single or multiple cells, providing more biologically relevant binding information at the local level, and yields more insight into how targeted drugs interact with proteins in abnormal signaling pathways, resulting in expedited drug discovery processes. In addition to examining cell-to-protein or peptide interactions, SPRm 200 allows you to study nanometer-scale binding activities of bacteria and viruses with antimicrobial drugs and develop new methods for nanoparticle drug delivery. These bacterial or virus-binding events are detected by measuring the changes of the wave pattern generated by the surface plasmonic wave. With its outstanding sensitivity, ease of use, and affordable price, Biosensing Instruments SPRm 200 is a label-free in vitro tool to study molecular interactions between drug and cell membrane proteins, bacteria, and viruses. SPRm 200, a new frontier in detecting and quantifying molecular interactions.